Ladies and gentlemen, boys and girls, welcome back to 6-3 in Chapter 6, page 316. I heard my volume's a little muffled, so I'm going to try my best to see if it's a little bit better this time around. Targets. I can find the sum of the interior angles of a polygon. I can also find the measure of an interior angle of a regular polygon. Vocab heavy chapter. We have sum. Hopefully we know that's addition still. Interior meaning inside. Polygon, okay, simple closed figure made up of 3 or more line segments. And then again, regular polygon, you'll find out what makes a polygon versus a regular polygon as we go on today. So here's a little chart that you might want to keep up to date. It's not in our textbook, but it is something we'll use and practice along. And so it's kind of an investigation of what type of triangle, okay, or what type of shape and how many angle measures there are that make up that shape. So a 3-sided figure we normally call a triangle, okay, and it looks like this. The number of triangles that make up a triangle is just 1, okay. So the sum, what we know about a triangle is that it's made up of 180 degrees. So that the whole sum is 180 degrees. Okay, so if you're following this same theme, let's see if you can kind of investigate, well, how many triangles make up a rectangle? A 4-sided figure, which is what we call a quadrilateral. Okay, so a 4-sided figure, it doesn't always look like this, is called a quadrilateral. Okay, and notice if you cut a quadrilateral in half, you make up 2 triangles. That means that we have 2 figures that angle measures are going to add up to 180. So we have 2 180-degree figures making a total of 360 degrees. So the sum of those inside measures is 360 degrees. And we're not going to do all of these, but we are going to want to know some names of figures. A 5-sided figure is called a pentagon. Okay, and it's a little fuzzy. How many triangles are in that? You kind of cut it from one angle, you're going to cut up to every angle that's not right next to it. So we created 3 in this case. So 3 at 180. Hopefully this is making some sense now on how we're getting these numbers. So for a total of 540 degrees. Okay. They all have different names. Hexagon, heptagon, octagon, nonagon, decagon, and so on. From here, and it's going to be 11 gon, 12 gon, and you just use the whole number. Okay, so we'll kind of fill in that chart as we go. But from that investigation, and that's on the top of 316, we can look at what's called interior angle sum of polygon. Interior angle sum. Seems kind of funny thing. So the inside, interior means inside, and sum means added, and polygon is that figure. So the sum of the measures of interior angles of a polygon is the number of sides, okay, is n minus 2 times 180, where n represents the number of sides on that type of polygon. So this is something we're going to use to determine the interior sum of the angles. So looking below, we have this, number 1 example. We're going to find the sum of the interior angles, and this one, the question is asking, find the sum of the measures of interior angles of a decagon, okay? So first we write the equation out. We write the sum of the angles is the number of sides minus 2, because there's always 2 less triangles, times 180, the sum of each triangle, okay? First we have to determine decagon, deca meaning 10. So this is a 10-sided figure. So a decagon has 10 sides, so we replace n with 10. We do 10 minus 2, which is 8. Multiply that by 180 because there's going to be 8 triangles that make up a decagon, and that's going to add up to, or multiply to, 1,440. So what this means is the sum of the measures of the interior angles of a decagon is 1,440 degrees. Okay? So we'll check our progress here using this equation. hexagon, octagon, and 15gon. Okay? For each option, you're going to use the equation shown here. You're going to use this equation, and n is going to replace the number. So for A, first we need to determine how many sides a hexagon is. A hexagon is a six-sided figure. So we're going to replace the side with 6 sides minus 2 times 180. So we get the side is equal to 4 times 180. So we get the side, or the sum of the angles, is 720 degrees, of course, okay? So the side, I keep saying that, the sum of all of the angles in a six-sided figure, all of them added up, are going to add up to 720 degrees. An octagon, we're going to do the same thing. First, we need to know octa, like octopus, has 8 legs, so that's an 8-sided figure. So the sum of the angles is the 8-sided figure minus 2 for how many triangles make up, times 180 degrees per triangle. So I get the sum times 180. So I get the sum of the angles in an octagon, all of the angles inside add up to 1080 degrees. Lastly, then for C, I'm kind of running out of room, a 15gon. So that's just as its name. So the sum is the 15 sides minus 2. There's always 2 less triangles times by each measure of triangle. So the sum is 13 triangles make inside that 15gon, each at 180 degrees apiece, for a total sum of angles of 2,340 degrees. You definitely want to keep this on a study guide in your notes. You want to keep that handy until you kind of get a hang of that each shape has 2 less triangles inside than it does sides. There's another topic called a regular polygon. So a polygon that is equilateral meaning all sides are congruent, equiangular, see that equal, angles, all angles are congruent. So all the sides are the same length, all the angles are the same measure. Notice these lines represent that all the sides are the same and all of these angles are the same, congruent. Okay? So they are called a regular polygon then. So all angles of a regular polygon are congruent, their measures are equal. So we can use what we know about a total measure, the sum of all of the measures, divided by the number of angles there are. Since they're even, we can divide evenly and find out how much each one is. So a real world example would be this house in Los Angeles, California, shown at the right, was designed by an architect, Frank Lloyd Wright. The exterior house consists of repeating regular quadrilaterals, so 4-sided shapes. Find the measure of the interior angle of a regular quadrilateral. So we're looking for one of the 4 angles. What is its measure since they're all the same? So step 1 is we use that form. So we know quadrilateral means 4, so we replace it here. And we find out that quadrilaterals have 360 degrees in total. So whether the quadrilateral is shaped like this, or it's kind of misshaped like this, all of these angles added together will be 360. Since this is a regular quadrilateral, it's more like a square, where each side is the same length, and each angle has the same measure. So to find one interior angle, you have to read directions, we know we struggle with. We're going to divide 360 by 4 because there are 4 sides of 4 angles. So we do 360 divided by 4, so that means that 90 degrees is the measure of one of the quadrilateral angles. Okay. A little less wordy option would be this. Okay. So if ever you're asked to find the measurement of one angle in a regular, it only works for regular polygons because then they're all going to be equal. So you you find one, then you know all of them. Use this instead. So it's pretty much the same one, but then you end up dividing by the number of angles of it. Okay? So you just divide by n once you find n. Okay, so that's the added on part. You definitely want this written down as well. Okay? Now if you want to do I for one interior angle, or what you want to do there. So let's try this. Let's find the measure of one interior angle in a regular hexagon. So we're going to use this formula from above. We know a hexagon has 6 sides. We're going to plug in 6 minus 2 times 180. And I like to put it over 6 right away. Hopefully you remember that you do the top first. So to work this out, we're going to do 6 minus 2. Okay, I'm just going to show down. So we're going to do 6 minus 2, which is 4, times 180. Then we'll divide by 6. Well, we still have some work to do on the top. So we do 4 times 180, and we get 720, but then we have to divide by 6. So the sum of all of them is 720, and if they're all the same, we can divide evenly by 6 for one interior measure. I'm kind of all over the place, so hopefully you're just a little neater, is 120 degrees. So one inside measure of a hexagon is 120 degrees if it is regular, okay? Which, if you look way back up at the top, that would mean one of these hexagon is 120 degrees. Each one of those is the same. Add it all the way up to 7. So give it a try here. Octagon is 8. Heptagon is 7. Polygon is 20. So I'm going to do one interior angle is 8 minus 2. There's 6 triangles in an octagon. Over, let's divide that by 8 for the number of angles in there. So then what we get is, and I kind of just go below, is 6 times 180 over 8. So we end up with 1,080 over 8, which is equal to an interior angle of 135 degrees per measure. For a heptagon, same thing. 7 minus 2 times 180 over 7 angles. And I'm just going to I for interior angle. For now, it's equal to 5 times 180 over 7, or 900 over 7, which then, let's see, when it's around, the direction say nearest 10, this is going to end up to be 128 and 6/10 degrees. Okay, sometimes they're not quite whole numbers, and that's okay. And then lastly, interior angle of a polygon would be, well, there's 18 triangles split over 20 angles. So we get 18 times 180 over the 20. So we get 3,240 split over 20 angles evenly gives me 162 degrees per angle. Okay? So notice we go up per side. So if you keep those formulas in mind, you should do a good job. So rewatch the video, check out somebody else's, especially if my volume is strange. Use the book and personal tutor and any other means. Come with 2 things you learned, 1 thing you're